Guys, coming to you with the notes from today, notes for similar polygons. There's quite a bit to this, but I'll be as thorough as I can. Similar polygons have the same shape, but not necessarily the same size. Okay, there's two things that you need to know about them. The angles are congruent, and the sides are proportional. Okay, so we're talking about similar. We're not talking about congruent. We're talking about similar. Okay, these two are similar. One's large and one's small. But if you notice, they do have congruent angles. They have congruent marks. So all this is true. Okay, and if that's true, we should be able to write a statement, similarity statement. A, B, C, D is similar. Similar just gets a little squiggle. G, H, I, J. So that's your similarity statement. And because the sides are proportional, we write an extended proportion. Okay, and as we do this, we put the sides together. So AB is this side. It goes with GH. So the first two here goes with the first two there. So we write that as a fraction. AB as a ratio to GH is equal to BC, the next two, as a ratio with HI, which would also be equal to a ratio of CD to IJ, which would also be equal to the bottom, AD with GJ. Okay, that's called our extended proportion. Okay, all similar polygons have what we call a scale factor. That's a comparison of the two numbers. It's the ratio of the corresponding linear measurements of two similar figures. All right, so once we decide if we are looking at similar polygons, then we can write a statement and give a scale factor. Okay, so first, are these similar? The first thing you want to check is angles. Angles are easy to check. So A is congruent to X, B is congruent to Y, C is congruent to Z. So angles are good. So a lot of times I'll just say angles check, that I did check that. Okay, now we need to see if the sides are proportional. So we're going to compare AB. If you look, it's between one swish in the box. It goes with XY. So 15 over 6 is one proportion, or one ratio, I should say. Okay, then we have 20 goes with 8 as another proportion, or ratio. I keep saying the wrong word here. And then 25 and 10 go together as another ratio. So these are my three ratios. If they are proportional, if they reduce down to the same amount, then we are looking at similar figures. So 15 over 6 reduces to 5 halves. 20 over 8 reduces to 5 halves. And then 25 over 10, once again, reduces. Okay, so as you can see, I did check my angles, my sides, my ratios. The comparison of the sides are proportional. They're all equal. So I can say yes. Triangle, and I'd want to write my statement here like we used to write. ABC is similar. We're not saying it's congruent, but it's similar to triangle. And look how we wrote that. 1, the box, and 2, 1, the box, and 2. And then we want to say that our scale factor is 5 over 2, or you can write it like that, 5 to 2. All right, so we're moving on to this example. So we want to know, are these similar and explain? Okay, let's check the angles. Okay, so angles are congruent. Check that. And then we want to know, are the sides proportional? So we're going to do MJ, which is 6, compared to WT, which has a ratio of 1. In the top, JK compares with TU. Okay, and we're getting a different ratio. So they're not similar because the sides are not proportional. Okay, so it's got half of the notes done. Let's go ahead and flip. All right, here's another example at the top. We want to know, once again, are these similar? Okay, so if they are, C and F go together. A and D go together. And B and E go together. So I would say, yes, the angles look good. So I could check that off. All right, now I want to do the sides. Now be careful with the side comparison. Look between the marks like we used to have to do. 1 to 2 marks has the 8. And over here, 1 to 2 marks has the 10. Then we can reduce that down. And that would reduce to 4/5. All right, then we'll compare another 2 sides. So C to B is between 1 and 3. F to E is between 1 and 3. 16 over 20. Okay, it's looking good. And then the last one, if we compare AB, which is 12 between 2 and 3, and between 2 and 3 on this one's 15, we also get 4/5. So we can say yes, and we can write a statement. So I'm going to call triangle ABC similar. Going to look, that's 2, 3, 1, 2, 3, 1, DEF. Okay, and why are they similar? The angles are congruent, the sides are proportional. All right, now we've got same questions here. Are these similar? If they are, write a statement, give a scale factor. Okay, so up here, 4/5 was our scale factor. So all 4 have right angles, so that looks good. So now we're going to compare. So the longer number, the bigger number here, the length as you would, goes with the length here. So angles are good. 15 compares to 20. We'll reduce that down. And then 10 goes with 15. All right, so 15 over 20 reduces to 3/4. And 10 over 15 reduces to 2/3. So they're not similar. All right, this one, we've checked the angles. We have right angles here in the corners. We have single swishes and double. So our angles look good. The angles are congruent. And we'll check our sides. So between 1 and 2, we have 12. Between 1 and 2 here, we have 6. 12 over 6 is 2. Okay, and we also have 12 and 6 again. Okay, on the bottom we have 18 and 9, 18 and 9, and 18 and 9. So I feel 18 and 9 is our next one we need to compare, which is 2. So we could say yes. E, A, B, C, D. You can pick any letter you want and go clockwise or counterclockwise. is similar. Started with 2, E, A, B, C, D. Then over here I could write, I want to start with 2, I could do T, S, R, V, U. And then our scale factor is 2. All right, so how do we use these similar polygons? So if they tell you that they're similar and you see the similarity statement, then we could find missing sides that we could compare. So on this problem, if you look, we've got to solve for x, we've got to solve for y. So we have a small trapezoid as it appears, 6y and x, and we have a bigger one, 6, well actually we have 9, 5, and 7.5. So we're going to set this up as a proportion to solve. Okay, so let's do x first. So I do it this way. I do x goes with 7.5. Then I need 2 more numbers that go together because I don't want another unknown in my proportion. I'm going to cross multiply. So this side of the trapezoid 6, and the larger side of this trapezoid is 9. 6 over 9. And then we'll just cross multiply. 9x, 7.5 times 6 is 45, divided by 9. X is 5. Okay, and then if I want y goes with 5. The top goes together. And then once again, I can use 6 and 9. 9y equals 30, divided by 9. Y equals 3.3 repeating. All right, the last part of this is scale drawings. A scale drawing is a drawing where all the lengths are proportional to their corresponding actual lengths. And a scale is a ratio that compares each length in the scale drawing to the actual size. Can you see those on a map sometimes? They'll have a little scale like 1 centimeter equals so much, or 1 centimeter equals so many inches. They can use any kind of scale they want. So for this last problem, 1 centimeter is 200 meters. If a scale drawing of the Golden Gate Bridge has a main span length 6.4 centimeters, use the scale above to find the actual length of the span. Okay, so the way I always do it is I take the scale and I put it as a fraction. And look, I have centimeters and meters. So whatever I'm given, I want to place it in the right spot. So centimeters are on top, so I'm going to put 6.4 on top. That way when I cross multiply it, the actual length that I find is going to be in meters. So 1 times x is x. 200 times 6.4 is 1,280 meters. Okay, guys, I hope you found this useful and not too complicated. And if you need anything from me at all, just send me a message. We're going to plan on doing our Google Meet on Wednesday at 11:30. That would be for third period, and 12:30 for fourth period. So if you would, I want you to join in with us then. And if you can't be there, I understand. I would want you to show proof that you at least watched it. And I hope you guys have a good day, and I'll see you later. Bye.